Alright, in this video we will figure out how to find the sample size required to achieve the given margin of error. We will round our answers to the nearest whole number. Well, let us recall that the margin of error, which I will abbreviate MOE, I know that looks like Mo, but the margin of error is equal to plus or minus 1 over the square root of the sample size. Alright, now we usually use the letter N to represent sample size because the word sample size takes up a lot of space. Alright, N is the sample size. So we're trying to find out what N is. Okay, so if they give us the margin of error is plus or minus 6.7%, then let's start with that. We're going to need to convert this to a decimal though, so 6.7% as a decimal, moving the decimal point twice, is 0.067, and that should equal, I'm going to disregard the plus or minus, that should equal 1 over the square root of the sample size. So it's just a matter of figuring out what this is. Now would be a good time to use the shortcut that we often use. When you have a variable in the denominator, remember that I can swap these two quantities with one another. So if I did that right now, that would give me the square root of n is equal to 1 over 0.067. So I want to get n, so what I need to do is get rid of that radical somehow. The way to make the radical go away is to square both sides like this. Alright, so that is going to lead me to the sample size. So n is equal to whatever I get right here. So what's this? 1 over 0.067 squared. Alright, so I've got 1 over 0.067 squared. That's this. Now I was supposed to round this to the nearest whole number, so that'll be 223. Got to round up. Alright, so that's how many people would have to be included in the sample size for the margin of error to be plus or minus 6.7%. Okay, let's do it again. So if this is the margin of error, as a decimal, that's going to be 0.23, and that should equal 1 over the square root of the sample size. If we do the swap thing that we do, that's going to give us the square root of n is equal to 1 over 0.23. Now if I square both sides like so, that should give me the sample size. So 1 over 0.23 squared. Alright, 18.9 to the whole number, that's 19. So the sample size would have to be 19 to have a margin of error of 23%. Okay, what about number 7? So as a decimal, move it twice, so this is going to be 0.054, and that should equal 1 over the square root of the sample size. Alright, doing our swap trick, that means that the square root of n should equal 1 over 0.054. Squaring both sides should give me that sample size. Okay, so 1 over 0.054. Alright, 343. Got to round up. Alright, last one. It's really just the same thing over and over. If I move the decimal point twice, that's going to give me 0.103, and that should equal 1 over the square root of the sample size. Do the swap. That tells me the square root of the sample size should equal 1 over 0.103. And once again, squaring both sides should give me the sample size. Okay, 1 over 0.103 squared. Alright, 94.2. That's 95, rounding to a whole number. That's false. 94. I'm getting sleepy, guys, which is weird because it's only 9 o'clock, so I have no, well, 9:30. Still, it's crazy early for me. 94 is the sample size. Alright, that's it for this concept. I'll see you on the next video.